So welcome. During this lesson, we want to look at calculus, the concept of stationary points. To get the stationary points, we follow the following steps. We have our equation as y is equal to x cubed plus 6x squared plus 9x. So to get our stationary points, we'll start first of all by differentiating or finding dy over dx. To differentiate, we normally do this. For example, we differentiate this polynomial term by term. If you are differentiating, for example, x cubed, we normally take 3. We assume there is a 1 here. 3 times 1 gives you 3x, and then you subtract 1 from the power. So you have 3x squared. That is the derivative. It's also called the gradient function. So using that formula, we shall find our dy dx for this equation, dy over dx, which is 3x squared minus, so you take 2 times 6, which gives you 12. Then when you differentiate 12, when you differentiate this, you have 12x. 2 minus 1 is just power 1, so there's a 1 there. You just don't have to write it because x implies 1x. Then plus, you assume there's a 1 here. 1 times 9 is 9, and then 1 minus 1 is 0, so x power 0 is the same as 1. So 1 times 9 remains as 9. So this is our derivative for that equation, dy dx. That is our derivative. So when you find the derivative, we find the stationary points, and we know that at stationary points, dy over dx is equal to 0, or the derivative of this function is equal to 0. So we are going to equate our dy dx, this one, to 0. So we'll have 3x squared plus, minus 12x plus 9 is equal to 0. To solve this equation, it is good that we simplify the equation. So let's simplify the equation by dividing all these values by 3. So when you divide by 3, you'll get x squared minus by 3, 1 by 3 of 4, minus 4x plus 3 is equal to 0. So you'll be left with x squared minus 4x plus 3 is equal to 0. And then we solve this equation quadratically as a quadratic equation. So to solve this equation, we can use the quadratic formula to solve that and get two values of x. And when you do that correctly, you get that the two values of x are x is equal to 1 or x is equal to 3. Those are the two values of x. So after getting the values of x, we can now find the values of y at the stationary points. So the first value of x is 1. Then if x is 1, what is y? We shall replace 1 in our original equation here. You have 1 cubed minus 6 times 1 squared plus 9 times 1 in our original equation, and that will give us the value of x, the value of y as 4. Then when x is 3, what will be the value of y? We shall go again and replace x with 3. So we replace x with 3 here. We replace x with 3 here. And also there. And we get our value of y as 0. So these 2 points are our stationary points. Those are our stationary points. Now we have the stationary point. Now what we want to get are the nature of the stationary points. In the nature of stationary point, we test whether the stationary point is a maxima or a maximum point, a minima or a minimum point, or a point of inflection. It's a maximum point if it is the topmost point in your curve. This one is a maximum point. It's a minimum point if it is the bottommost point. So this one is a minimum. So we shall test that, and we test using our table with the values of x. So we shall have our table where x is 1, the neighborhood of x is 2 and 0. Obviously here the dy dx of the ingredient is 0. What about that 2? You replace these 2 in our dy over dx, which we were able to find at this point, which was 3x squared minus 12x plus 9. So our dy dx is there, so you replace 2 with our dy dx, and you are going to get, first of all, you replace 0, and when you replace it with 0, you are going to get that our value is a positive value. When you replace with 2, you are going to get that it is a negative value. That is when you replace 2 in our derivative. You replace 0 in our derivative, you will get a positive value. You replace 2 in our derivative, you will get a negative value. So when it is positive, 0, and then negative, we normally have the positive as an upward sloping curve, a point which is stationary, and a downward sloping curve. So therefore, this point that we have here, we state that 1, 4 is a maximum point. The other points we also tested. We have 3. The neighborhood of 3 is 4 and 2. 3 is definitely the dy over dx is definitely 0, because that is where our point is stationary. And then we replace with 4. When we replace with 4, we are going to get a positive value. We replace with 2, we are going to get a negative value. So that means our curve is going to be downward sloping, a point of stationary point, and then we have the upward sloping for the positive part. So this point is 3, 0. It's a minimum point. So minimum or the minimum point. So once you get there, you can now find sketch the points. To see whether so you draw a Cartesian plane with the y-axis and the x-axis to sketch the points. So in our Cartesian plane, the first point is 1, 4. So this is where 1 is, 1, 4. That is our point. Remember, this point is maximum. The other point is 1, 2, 3. We have 3, 0. This is point 3, 0. It is our minimum. So because this is the maximum point and this is the minimum point, you shall draw a curve or a sketch. You sketch a curve such that this is the highest point and this is the lowest point. This is the maximum point. and this is the minimum point. So you sketch a line. When it reaches here, this is the turning point. It gets to the bottom part and it moves upwards. That is the minimum point and the maximum point. So that is how we normally do this kind of a question.